morning, students. And today's class is uh, Opencast Mining, the related terms with the Opencast Mining, and different terms are there. Different terms are associated with the Opencast Mining, and we will discuss different times, different terms which are related to the Opencast Mining. There are a number of terms are there. All are related to the Opencast Mining. Outcrop is there, overburden is there, face is there, bench is there, height of the bench is there, and slope of the bench is there, width of the bench is there, floor of the bench is there, depth of the hole is there, spacing is there, burden is there, toe is there, crust is there, back break is there. So these are the different terms which are associated with the Opencast Mining. Before before entering into the excavation of the mineral, the excavation of the mineral by the Opencast Mining, and we must be very much familiar with the different terms of the Opencast Mining. So after that, when we come to know the different terms of the Opencast Mining, then it will become very easier to know, to understand the concept of the Opencast Mining. It is there, and basically the concept of the Opencast Mining is there. Below the surface of the earth, some types of minerals are available, very much available. Suppose coal is there, iron ore is there, and copper is there, aluminum is there. Different types of minerals which are occurring, which are available below the surface of the earth is there. So some type of minerals are which are available below the 50 meters of surface of the earth. Some of the minerals which are available at the deepest points, more than 300 meters. And before that, actually, the Opencast Mining is very much modernized and mechanized, and the revolution of what we can say, all the methods of Opencast Mining are revolutionized. So conventional Opencast Mining, and now highly we are reaching to highly mechanized Opencast Mining is there. The conventional Opencast Mining actually, as per the basic concepts of the mining is there. The drilling, the blasting, the loading, and the transportation. These are the different types of the different phases of the mining is there. Maybe the underground mining, or maybe the Opencast mining. Whatever the mining is there, these are the basic concepts of the mining. And even for the Opencast mining also, the same phases of mining are there. Drilling, blasting, loading, transportation, it is there. So the drilling, actually the core drills are there, or the jackhammer drills are there. With the help of a jackhammer drills, we establish the holes, or we drill the holes. So after drilling the holes, and we make the blasting pattern, and in the blasting pattern we put the explosive, and we charge with all the holes are charged with the explosives, and different types of explosive we use. Generally ANFO material, liquid oxygen, and different other material explosive which is used. Slurry explosives we are used. Generally the slurry ANFO material, ammonium nitrate fuel mixture. The ANFO material may be the plant mixed slurry, maybe the site mixed slurry. Using the vehicle, charge the blasting holes with the ANFO, the explosive. After that, so those are connected in the series pattern to the exploder, and we blast it out to the blasting pattern. So the blasting is done. In the blasting, a lot of material is achieved. It is there, and after that, the loaders, lifters are there. The hydraulic shovels are there, rope shovels are there, which come over there to the face, to the bottom of the bench, and there the hydraulic shovels which pick up the material and dump over the dumpers. It is there. So the lifting is done by the different types of shovels are there. Generally the rope shovel we use there, and hydraulic shovel also we use there. So 3 or 4 different types of shovels are there, and all the shovels which is having the capacity may be 2.4 meter cube to 10 meter cube. Very biggest shovels are there. with the help of the shovels, the coal material, the blasted out coal material is lifted up and dumped over the dumpers. So the depending upon the size of the open cast mining, actually the size of them maybe 1 million tons per annum to 10 million tons from generally it varies, and very biggest mines are there, even 50 million tons, 100 million tons, 200 million tons, very biggest open cast mines are there. So all the mines where a lot of this one, where a lot of the coal is excavated. So depending upon the size of the distance, the explosive charge there and they blast it out, and the the coal is lifted by the high powered shovels, and the range of the dumper varies from 35 tons, and 35 tons, 85 tons, 105 tons, 135 tons, 185 tons, 235 tons. So this is the range of the capacities of the various dumpers we use there, depending upon the capacity of the mine, capacity of the depending the size of the mine, size of the project it is there. So the dumpers carry out the material from the mining that point to, and this one the where the waste material is dumped, and to the yard the material is carried away by the dumpers, it is done. So this is about the open cast mining, where actually the surface cover is maybe the 50 meters. In the older days the surface cover is, it was only the 15 meters. Now with the range of mechanization, it is highly mechanized, and the open cast mining is very much mechanized. Now we are reaching up to even 300 meters overburden is there, the waste rock is there, under the waste rock the mineral is there, the coal is there, the iron is there, the copper is there, which is available at 300 meters depth from the surface. The 300 waste rock, the overburden material is removed, and which is removed very economically. Technologically it is viable, and economically it is viable. Even 300 meters rock, the waste rock is removed, even the project runs in the profits, it is there. So the technology, the mechanization is highly very much improves, and the mines are becoming highly mechanized, mines the mines are becoming very highly mechanized. And OMS, that we are getting the OMS from the open cast mining is generally output per man shift. OMS is the output per man shift. One man produces in one shift, that is more than 30. So the range is 30 to 50. After 50 also, the one man is producing the 50 tons of the coal, 50 tons of mineral per shift. So it is called the OMS. The OMS is very much high in the open cast mine. Even the mineral which is available at 300 meters depth also, and that is the project is economically viable, and economically and technologically it is viable. So it is highly feasible, what we can say, technologically is feasible. So using Indian machinery, using Indian make machinery, and using the different types of blasting techniques, different types of other techniques, and we are producing the production, and technologically we are producing the production very with with the highest OMS, and we are producing the much production with higher productivity, and we are generating the profits. So this is the general concept of the open cast mining. So we are touching the mineral which is available, and beyond 300 meters also we are excavating, we are able to excavate the mineral, maybe the coal, maybe the iron. We are able to excavate the mineral with a higher benefits. So with the use of that technology, with the use of high capacity machines, so we are able to excavate this thing. So anyway, this is the basic concept of the open cast mining, and further getting the in details, the getting into the details of the open cast. So we must be the familiar, we must have the this thing, the familiarity with the different terms which are associated with the open cast mining, it is there. So now, just now before we discussed the open cast mining, maybe there. So this is the surface. This is the surface of the earth, and this point where the mineral is occurring, where the mineral is occurring, and this is the surface of the earth, we can say. So the mineral may be 50 meters to 300 meters. Just now we discussed the mineral may be available at 50 meters, and the mineral may be available at 300 meters. Suppose the mineral is available at 50 meters, and then suppose the height of the bench is the 10 meters generally, then the 5 vertical benches are needed. The 5 vertical benches are needed to touch the mineral of to touch the mineral bed. It is there. Suppose if the surface cover is 300 meters, then the height of the bench is 10 meters. Then 30 vertical benches are very much needed to touch the mineral bed. So it depends upon the mineral occurrence from the surface of the area, and we consider and the height of the bench also. Height of the bench generally it varies from 10 meters to the 30 meters. For small mechanized mines, the height of the bench is the 10 meters. For higher mechanized mines, the height of the bench slowly increases. Even up to 30 meters also, the height of the bench it is there. So even suppose bucket wheel excavator it is there. So where the height of the bench is nearly 30 meters, because large tons of overburden material is removed, and the coal is also removed there. The height of the bench is very much more. So it varies from the 10 meters, that it goes on increasing 10 meters, 15 meters, 20 meters, 25 meters, 30 meters. So after 30 meters, the height of the bench is there. Even suppose the very small mines, very quarries are there, where quarries there also the height of the bench is more than 5 meters. The 5 meters to 10 meters height of the bench is there. Height is there, and width is there, and the slope is there. So these are the different parameters of the bench is there. Suppose when all we actually before at the beginning, suppose we take the 50 meters for example. Suppose the mineral is available at 50 meters below the surface, there the 50 meters. Suppose the vertical bench is the 10 meters, and like that the 10 meters into 5 vertical benches are very much needed to touch the mineral. Anyway, first before that, the box cut is made. The box cut is made at the beginning, and from that onwards, the OB is converted into different benches, different 5 benches are there. So the bench is nothing but it is similar to the step. The step is having the width of the bench, the height of the bench, and the slope of the bench. Same. What are the different features the step is having? The same features, the same and characteristics the bench is having. The step is small in size, and when you see a bigger step is there, the bench looks like a bigger step. So actually there where the step is having a vertical side, but here the bench is having a slope. A certain slope is the bench is there. The height is there, the width is there, the slope is there, and the angle of this in the angle of slope is there. So different other parameters are there. So all these things are there. Anyway, when 50 meters, when the mineral is occurring below the 50 meters, there height of the benches the 10 meters, generally the 5 vertical benches are needed. So the OB is converted. Suppose 1 acre land is a 1 acre land. This one the mineral is lying at the 50 meters. So 1 acre land with the help of by driving the box cut, from the box cut onwards, different benches are there. Vertical 5 benches are there. So the vertical all over the area, all over the 1 acre area, all the area, the overburden is converted into different benches. So The benches are extended. The benches are by excavating, by the blasting out, The height is actually we drill the hole from the bench, from the bench downwards, from the bench down. So the bench is excavated. So we are excavating the benches. The benches are advancing. Likewise, all the benches are removed so that the overburden material is removed. In a similar fashion, the coal is available below the 50 meters. The coal is suppose a 20 meters coal is there. The 20 meters coal may be converted into different types of art. The height of the bench may be suppose a 10 meters is there. 10 meters means the two benches are created there. Suppose if the suppose again 50 meters coal is available, 50 meters coal is available, and the 50 meters coal is converted into 5 vertical benches. So the vertical benches are excavated, the coal is excavated. So the coal and the overburden, those are excavated in the form of the benches. The benches are advanced by excavation. The benches are plastered. In the same fashion, in the similar manner, the total overburden and the coal, the mineral bed is excavated. Wherever the mineral is available over the area 1 acre, the 1 acre area is excavated, may be available at the 50 meters below the earth at the floor. So from that onwards, the mineral is excavated by laying the different benches. The benches are excavated, the benches are exploited, and the overburden material, the overlying rock is excavated, and the mineral bed, maybe the coal, maybe the iron, maybe the copper, are excavated. The overburden and the coal both are excavated in the form of benches. The benches are blasted, and the blasted material and picked up and lifted up and transported from the surface to maybe the dumping yard, maybe 5 kilometers away, or the coal screening plant maybe 5 kilometers or 10 kilometers away from the mine. So both the things are transported that point to the forward this thing. So yes, so this is the different things, different concepts of the open cast mining. Anyway, before that, and this one different the terms we did. Outcrop. The outcrop is nothing but actually the minerals are formed by the igneous rock, by the sediment rock, by the metamorphic. So mostly by the suppose the coal is there. The coal is formed by the different theories. Drift theory is there, and in situ theory is there. So million years back, maybe the Triassic age, maybe the 65 million years back, Triassic to Tertiary age, 65 million years back, actually all the vegetation or the trees are actually are due to the earthquake, the trees are buried. The trees are buried in the earth, and the passing of the millions of years, the wet vegetation of the trees, the carbon, the wet form of the carbon is transformed into the dry carbon due to the bacterial and chemical action. The wet vegetation is converted into the coal, and this is called the coalification. So and the two theories are proposing the coalification. The in situ theory is proposing, and drift theory is proposing. So and suppose so naturally the coal is available, the coal is found right now. Actually, if the coal is very near to the surface, when the coal is exposed to the surface, and that particular point is called the outcrop. Wherever the coal is, actually the coal bed may be there. So suppose this is the surface of this thing. Suppose the coal seam will be like this. The coal seam will be like this, and this seam which is touches the surface point, and this point is called outcrop. So by seeing the outcrop, we can imagine the presence of the occurrence of the coal. So we can definitely estimate the coal must be very near to the surface. So we can expect the process of the mining. We can suppose how many benches have to be laid out, how many OB benches have to be laid out, how many coal benches have to be laid out, and different things can be very much known by seeing this outcrop area. And sometimes the outcrop maybe nearer to the surface, but due to the soil, it is concealed, and that type of outcrops which are called the concealed outcrops. But the concealed outcrops generally misguide the miners. So actually, but in that cases, generally the geological GSA must have done the survey, must have procured the borehole data, and as per the borehole data, the outcrop can be identified. The outcrop can be identified, can be estimated. So the occurrence of the mineral from the surface where it is occurring can be known easily, and the size of the OB to be removed is also very much known. So this is about the outcrop. And the next is the overburden. The overburden is actually, as we discussed, the coal is available below the 50 meters, and over the 50 meters, and over the coal, the waste rock material is there. That particular waste rock material is called overburden. So the overburden has to be blasted out and then removed, and actually the mineral, maybe the coal, maybe the iron, is exposed, and the coal is also converted into different benches, and the benches are excavated in the form of the benches, in the form of exploitation of benches, in the form of excavating the benches, the coal is exploited. So the overburden which is overlying the mineral is called the overburden. It is the waste rock which is lying over over the mineral, over the coal. So the waste, first of all, before starting the open cast mining, the overburden, the waste rock has to be removed. The waste burden must be converted into different vertical benches, and the benches are removed. That is it. And then this is called the overburden. And the overburden actually different depends upon the stripping ratio. Something is there. It is 1:5, 1:4, 1:4 thing. It is there. So it is a ratio. It is a ratio of volume of the OB removed per ton of coal. So the stripping ratio is nothing but it is the ratio of the volume of overburden material removed from 1 ton of coal to be raised is called the stripping ratio. Generally, the stripping ratio is 1:5. So more than 1:5 is not economical, and below this because the overburden 5 parts of one part of this one, the coal is removed, and the 5 parts of the ore will be removed. But when the mechanization is very much more, and in that case, the stripping ratio can be very much more. Can be more. Even the technology is more, and economics and the profits generated by the project must have been very much high. Why? Because the technology is high range of technology we are using, high range capacity machines we are using, and technically, mechanically, they are very much feasible. So overburden depends completely on the stripping ratio. And the older mines, the stripping ratio, it is generally 1:5. 1:5. Now, it is totally the scenario of the mining, the scenario of the open cast mining is changed. Even we are able to mine out the material which is available beyond 300 meters below the surface of the it is there. So that is overburden. Anyway, this is the outcrop and the overburden. And the next one is the bench. As we discussed, the overburden or the mineral or the coal is removed in the form of bench. The benches are excavated. So the bench is there. We lay the benches. The height of the bench is generally the 5 meters to it is generally 5 meters to 30 meters. 5 meters is there, 10 meters is there, 15 meters is there, and like that it increases up to the 30 meters. Suppose highly mechanized, where biggest the shovels are used, and the highly mechanized, the coal drills are, and the OB drills are, high capacity drills are used there. Then the size of the size of the height of the bench must be very high. Generally, for the conventional mines, it is the 5 meters and less than 10 meters. The height of the bench is there, and for the mechanized mines, and the height of the bench generally increases. The 10 meters, 15 meters, 20 meters, 25 meters, 30 meters, up to 30 meters. The height of bench is there. when the shovel boom, when a bigger shovels we are using there, the boom of the shovel can lift even up to 30 meters. It is there. And then the height of the bench can be, we can use like that. It is there. So the suppose bucket wheel excavator, where the boom height is very lengthy boom is we are using there. So a lengthy boom, even it can approach even 30 meters of height of the bench also. So the OB material, I mean the coal material, which is at the 30 meters also easily lifted up by the bucket wheel excavator. So when mechanization is very much poor and the height of the bench even it touches 30 meters. So 5 meters onwards, the height of the bench is 30 meters is there. For the conventional mines, the height of the bench is less than 10 meters. It is saying. So this is the bench, and this one is called the slope of the bench. The slope, the suppose this is the angle of the bench is there. Suppose the angle of the bench, suppose maybe the 45 degrees is there, and different materials are there. The alluvial soil is there, and different soils are there, and the rock is there. Suppose soil is there, alluvial soil is there. There, actually, the slope of the bench not more than 45 degrees. Why? Because the slope of the bench is more than 45 degrees. The slope fails down. Then the bench of the OB fails down. A failure occurs. So the mining is not possible. So there, the slope of the bench in the alluvial soil must not be more than the 45 degrees. For the rock, for the suppose a granite rock is there, overburden is the dolerite rock is there, the igneous rock is there. Igneous even there the slope, the angle of the slope of the angular slope may be more than 45 degrees, even 55 degrees, 70 degrees also. It is very stable and strengthy. The falling, the failures do not occur. The failures do not occur to the slope. Why? Because a stone is there. The stone is having higher stability than the soil, than the alluvial soil. Suppose alluvial soil is there, the angle of the slope must be less than the 45 degrees. It not be more than 45 degrees. Why? Because it increases more than 45 degrees, the failure occurs, the total the mining becomes the mess and fuss. So the mining is not at all possible there. So the slope angle must be less than the 45 degrees, must not exceed 45 degrees. For the igneous rock, for the strengthy rock, so the quartz rock is there, dolerite rock is there, and different other igneous rocks are there, which are in the OB. Then the slope may be more than 45 degrees. There, the mining is possible. So this is the slope of the rock and height of the rock, and this one, and this one. This is the height of the rock. Height of the rock generally what we call maybe 5 meters to 30 meters. For the conventional mine, the height of the bench is the 5 meters, and for the mechanized when we use bucket wheel excavator, then the height of the bench is 30 meters. When mechanization starts increasing, the height of the bench is also very much increased. It is there. So the height of the bench is 30 meters. It is there. So this is the height of the bench, and the width of the bench. This is called the width of the bench. Naturally, the width of the bench must be more than the height of the bench. Why? Because where we place heavy earth moving machinery, the machineries are there. Suppose drill machines are there, and the coal drill machines are there, and overburden drill machines are there, and they are heavy. The weight is thousands of tons, tons weight is there, hundreds of tons of weight is there. So they are moving. They are moving on the bench. Hundreds of tons of weight is there, moving on the bench. So the bench must be very much stable, and still for the stability, and the width of the bench must be more than the height of the bench. Suppose the height of the bench is 10 meters is there, and the width of the bench must be more than the 10 meters, maybe the 15 meters, because the shovels, different types of high capacity shovels, and different dumpers, high capacity dumpers, and the gold drills and the OB drills, which are loitering, which are moving on the top of the bench. So the width of the bench must be very much more. It is there. So width of bench is there, and the slope of the bench is there, and the height of the bench is there, and this is the bottom of the bench is there. So these are the different terms which are related this way, and the top one, and this is called the face of the bench, and then the first one, and almost the topmost point is called the face of the bench. And sometimes this is called the crest of the crest of the bench, and this on the bottom and the toe of the bench, and the topmost, the peakmost point, and the last point is called the crest of the bench, and last this point is called this one, a toe of the bench is nothing but the unfragmented area at the bottom of the bench is called the toe of the bench, or else it is the difference between the projecting slope beyond the crest. Suppose this is this one, and this is the crest, and this is the projected unbroken this one, and beyond the crest. Suppose this is the crest, something it is there, and this is called the toe. Generally, the toe is formed at the bottom of the bench, generally, and the toe cannot be, generally in many cases, the toe cannot extend to the crest of this one. But in many rare cases, the toe extends to the crest of the bench. Suppose if this is the crest of the bench, the toe is there from this point. This is called the toe of the, what we call the toe of the bench. So from this point, maybe it is formed this point place, and the toe can be expanded up to the crest of the bench. So it is the, what we call the projecting the slope beyond the crest is called the toe. Projecting the plane, the projecting the slope beyond the crest is called the toe, or unbroken, unfractured the core which is formed at the bottom of the bench is called the toe. So that is toe. So this is the face, and the bench, this is there. And different other things are there, and the spacing is there, the burden is there, and this is also, this is over, and this is the crust is there, and drag is there. So we will see the things, and finally, and the parameters and the bench depends upon, and that also we will see. And the first one, and this one, the burden is there. It is the distance between the face means, and this is the face point from the blast hole. And different types of blast hole we laid out. Suppose mechanized mines are there, the 50 holes are we laid out there, and the first hole is there, and the distance between from edge from the edge of the face, what we call the face, the edge of the bench is called the face. So from the face to the first hole is called the burden. So the distance must not be very much greater, and the distance must not be very much shorter. So if the distance is very much greater, and this one, a crater is formed. So unblasted rock is formed. Suppose this is our, suppose burden is there, and when the burden is more, so unfractured rock remains there. It is there. This is the burden. When very short is there, then excessive fragmentation occurs. So, and it becomes very powdery coal is obtained, and we will get the powder coal. So the coal gets into powder. So, and that is not valuable, and we cannot lift the coal. It is there. So the coal shall not be converted into the powder shape. The powder coal cannot be lifted there. The slurry cannot be lifted up. It is there. So it must be in the form of borders, and must be in the form of a sized coal material. So the burden, the optimum burden must be there. It does not be very much greater. If it is very much greater, then boulders are, when crater is formed. And if it is very shorter, high fragmentation occurs, and the high fragmentation causes the powder. It makes the coal powder, and the powder coal cannot be lifted up. It is there. So this is the burden. And one more thing is the spacing is there. Spacing is the distance between the two holes. The distance between the two holes is called the spacing, and this is also there. Suppose the bench is, this is bench is here. The 50 holes, 50 holes are laid out. 50 hole blasting holes are laid out. So the distance between successive holes is called the spacing. So generally optimum spacing we use there. Suppose the spacing is very much more, the crater is formed. The crater is unbroken, unfractured rock remains there. Unfractured, unbroken, rock remains there. So that is when we use the bigger spacing. When the spacing is shorter, the excessive fragmentation is Suppose a coal bench is there and the powder coal is obtained. So the powder coal is very troublesome, and it is getting lifted up by the shovels and dumping over the dumpers. It is there. So many problems are there when powder coal is formed. So the spacing must be, the burden and the spacing must be very optimum, not too much greater, not too much shorter is there. The optimum, this one is and the taken is there on this one. Finally, other two things are there. The crust is there and the back break is there. The crust is actually, suppose the surface is there. The line joining elevated points from the floor along the bank. Suppose this is the bank, this is the, and what we call crustal part may be like this, crustal part. So the line joining the crust, the highly elevated points on the surface is called crust. The crust of the earth, highly elevated points. The line joining the elevated points from the floor along the bank is called the crust. This is called the crustal plate, the crustal and the crust of the earth. So on the bank, on the surface, the elevated points, a line joins the elevated point, it is called the crust of the earth. And then the next one is the back break is there. So the fractured plane beyond the blast hole, suppose the holes are there, fractured beyond, suppose somewhere, that one. The other benches, the top bench is also blasted out. The top bench is blasted out, and which is the fracture frame beyond the blast hole. Suppose from this point we laid out the blast hole. From this one, beyond this blast hole also, the zone is fractured, and the particular this one is called the line joining fragments from the individual crater point, individual this thing is a fracture plane found beyond the blast hole is called back break. So the holes, suppose the holes are laid from this point only, and beyond this one, somewhere this one, the here, the zone is also fractured. Particular that zone is also called what we this thing, the back break. What that is called, the back break. So back break is nothing but, so beyond the blast hole, the zone is fractured, the area is fractured, and the particular area, this one is called back break. What we call the back break. So these are the different terms which are this way. And finally this one, the bench, the different parameters are there. The parameters, the height of the bench depends upon 5 parameters are there, and they depends upon the thickness of the overburden is there, hardness of the strata is there, equipment size is there, and nature of the bedding layer is there, and degree of the wetness is there. So these five parameters which decides the bench height. Generally the bench height is the 5 meters to 30 meters, and just we discussed for the highly mechanized mine, when the mechanization increase, that is this the equipment size. When the equipment size is increased, and because economics, and we produce even depth point also, even 300 meters OB has to be removed, and that area also that is economically viable. So technically feasible, economically viable, it is there. So mechanization increases, automatically the size of the bench maybe the 20 meters, 30 meters, it is there. And this thing, the thickness of the overburden, very much high. Suppose 300 meters OB has to be removed. Suppose if you put the 5 meters, how many vertical benches has to be removed? Suppose and the 20 for every 100 meters 20 like that, 60 vertical benches have to be laid out. So that is very difficult. Then suppose for 300 meters OB is there, if you put 30 meters to the height of the bench, then and how many 10 vertical benches are needed. 10 vertical benches are needed, and that is very much easier to mine out than 300 meters the vertical overburden. It is suppose if you put the 5 meters, 300 meters, 60 vertical benches. It is the mining is complicated and mining is very difficult, so we cannot mine out there. So suppose 300 meters of OB is available there. The size of the OB, maybe the core is very soft, then we can use the bucket wheel excavator. So with the help of bucket wheel excavator, then that can be this and that can be removed. That is there. So we can lay out, we can lay out the 30 and the 10 vertical benches. The height of the benches 30 meters. That for 300 meters removal of the overburden, and 10 vertical benches are required. So that is there. So this depends on thickness of the OB. Hardness of the strata. When hardness of the strata is very bad, which is very still the igneous rocks are there, a quartz is there, and a corundum is there, and that type of apatite is there, and like that materials which are available in the rock face. So the height of the bench can be very much more than 10 meters. Because suppose alluvial soil is there. Suppose if we put alluvial soil, the height of the bench is 10 meters, then the bench collapses. The bench collapses, and the hazards happen out there. It is there. So what the hardness, when the hardness is there, then the height of the bench can be more. It is there. When the hardness is less, the height of the bench can be reduced. In the alluvial soil, alluvial soil, where the height of the bench is very less. Where a strengthy rock is there, where the quartz is there, where the apatite is there, where the corundum is there, different other materials are there, and there the height of the bench can be very much more. It is there. And nature of the bedding plane. Suppose it is a faulty mine is there, then height of the bench cannot be very much more. The faulting line limits the height of the bench. It is there. So the nature of the bedding plane is there, and degree of witness is there. And dignity of witness is there. Actually, what is that? When the strata may be water bearing strata is there. The lot of plenty of water is there. When water is there, automatically the height of the bench is reduced. Suppose the height of the bench is more than 10 meters in a water bearing strata, the slope failure occurs. The failure occurs along the slope. It is there. So the total slope falls down, and total bench collapses, and a major accident may occur. It is there. So when degree of witness is there, if it is a water bearing strata, then the height of the bench must be very lesser, must be around 5 meters. It is there, and the 5 meters is viable, and not less than the 5 meters, because the mining is not at all possible and less than 5 meters. Suppose it cannot be more than 10 meters in a water bearing strata. Suppose the OB is there. The OB has got a feature of water bearing strata, and that it can be there. The height of the bench cannot be more than 10 meters. It is there, and these are the different factors where the bench of the height depends. The factors which influence the height of the bench is the thickness of the overburden, the hardness of the strata, equipment size, and this one, the mechanization, the range of the mechanization, nature of the bedding plane, and the degree of wetness. So these are the different factors which influence the size, the bench height. It is there. So in this class we discussed the number of the number of the terms which are associated with the open cast mining is there. From the box cut onwards, suppose maybe the 50 meters the mineral may be available. So we lay the box cut. From the box cut to the surface, a number of vertical benches are laid out, and all the vertical benches are laid out along the total area of the project, and the OB is also converted into different benches, and the mineral bed is also converted into different benches. It is there. So totally all the mineral benches are removed, all the mineral benches are excavated, all the overburden benches are excavated. It is there. So in this class we discuss our crop, we discuss our OB, we discuss the different parameters of the bench, height of the bench, and the slope of the bench, the angle of the bench, and the width of the bench, and the crest, and the crest, and the toe, and the toe, and the crest, and the crust, and the back brake, and the spacing, and the burden on the floor of the bench. So these are the different the things which are this thing which are connected to the open cast mining. And thank you.